Alright, I chose to do number 4 on problem set 2 to explain. The problem reads, suppose each single character stored in a computer uses 8 bits. Then each character is represented by a different sequence of 8 zeros and 1s called a bit pattern. How many different bit patterns are there? That is, how many different characters could be represented. So yeah, this kind of just it's pretty straightforward. It just uses the kind of powers with how many different places a bit pattern can represent, and since there are 2 options, a 0 or 1, it's going to involve a power of 2. So in this case, we have 8 different combinations of two possibilities, which gives us, as I showed here, 2 to the 8th or 256 different bit patterns that an 8-spot binary string can represent. The second one is how many bit patterns are palindromes, so the same backwards as forwards. This takes a bit more of a involved calculation. So I found that the number of palindromes are calculated by different varieties of the first 4 bit, which must also have counterparts in the last 4 bits. So I just kind of used again the power calculation of the first 4 bits being 16, and that there must be 16 bits that are exactly the same in the last 4 bits. So yeah, that's B. And then for C, how many different bit patterns have an even number of 1s? So in bit strings of almost any length, the last bit is going to be what calculates the 1 spot, or I'm sorry, not the 1 spot, but in decimal, whether it's even or odd, because it either adds a 1 or a 0, depending on if it's a 1 or a 0 to the value of the decimal digit. So the number of evens is calculated by either taking half of the whole or not considering the last bit, since it decides even or odd. So for C, it's going to be 2 to the 7th, which is just, like I said, just a consideration of only 7 of the digits. So 128 should be even numbers. Thank you.